Welcome to the Deep Dive. Today we're plunging into, well, a cosmic mystery that really has everyone talking. A brand new visitor from way beyond our solar system.
Yeah, it's a seriously rare event. We're talking about Three-Eye Atlas.
Exactly. Discovered just what, July 1st, 2025?
Mm-hmm.
And it's only the third confirmed interstellar object we've ever spotted.
It's pretty amazing, isn't it? I mean, every time one of these pops up, it just pushes what we thought we knew. A real wanderer from light years away.
Absolutely. And when something this rare shows up from so far out, the big question pops up almost immediately, right? What is it?
Mm-hmm.
Is Three-Eye Atlas just a natural interstellar comet, doing its thing? Or could it be something, well, something a lot more extraordinary, maybe an alien probe?
That's the core of it, yeah. And what's so interesting here is watching how the scientific community actually wrestles with that kind of possibility. How do you weigh that against what we already know?
Right. So our mission today really is to unpack all of that. The claims being made, the evidence that's been put forward, and how the wider science world is reacting.
We want to help you get a handle on this whole debate, understand what the community is actually thinking. It's not just what is happening, but how science deals with these really big, potentially paradigm-shifting claims.
Exactly. And to do that, we're looking at a couple of key things. There's a preprint study from a well-known Harvard astrophysicist.
Fuzzy Logue, yeah.
And then there's the, frankly, overwhelming response from pretty much everyone else in the field. Detailed observations, some pretty sharp criticisms, too.
It's a great snapshot, really, of scientific discussion happening right now out in the open.
Okay, so let's start with the visitor itself, Three-Eye Atlas. Tell us a bit more about it.
Okay, so detected July 1st, 2025. It's moving incredibly fast, over 130,000 miles per hour.
Wow.
Which is about 60 kilometers per second. And it's not small either. Estimates are somewhere between, say, 7 and 15 miles across, maybe 10 to 24 kilometers.
That's pretty substantial.
Yeah. And when they first saw it, it already had a visible coma.
Okay, so a coma that's like the fuzzy atmosphere around it, dust and gas.
Exactly. Typically from ice vaporizing as it gets closer to the sun. Classic comet stuff, really.
Right, so that initial observation sounds pretty straightforwardly like a comet.
It does. That visible coma is a really strong pointer towards a natural explanation. But then, yeah, we have to talk about Avi Loeb.
The Harvard astrophysicist you mentioned. He's got a history with this kind of idea, hasn't he?
He does. He's known for, let's say, bold hypotheses. Back in 2017, he suggested Oumuamua, that was the first interstellar object we found, might have been alien tech.
I remember that. Caused quite a stir.
It did. And then more recently, 2023, he made some controversial claims about finding materials from what he argued was an interstellar meteorite. He's definitely pushing boundaries.
And he even started the Galileo project, right, back in 2021, specifically looking for alien technosignatures.
That's right, seeking actual evidence of extraterrestrial technology. So you can see how that mindset, that focus, sort of shapes his approach when something like Three-Eye Atlas comes along.
Okay, so how did that play out here?
Well, that curiosity led him, along with two co-authors, Adam Drowell and Adam Hibbard, to publish a preprint study around July 16th or 17th this year.
A preprint, meaning not yet peer-reviewed.
Correct, not gone through the formal review process yet. And in it, they basically proposed that, hey, maybe Three-Eye Atlas isn't a comet. Maybe it's an alien spacecraft.
Okay, so what arguments did they actually make? What evidence did they point to for such a radical idea?
Well, one of the main things was this non-gravitational acceleration. The object's path isn't just dictated by gravity. Something else is nudging it slightly.
Which happens with comets, right? Like little jets.
Exactly. Usually it's gas and dust escaping, acting like tiny thrusters. But here's the key part of their argument. They claim this acceleration was happening without visible outgassing, without that obvious fuzzy coma activity you'd expect.
Huh. So a push, but no obvious cause like venting gas. That is interesting. What else?
They also highlighted its orbital path. It's got this retrograde orbit, meaning it goes around the sun the opposite way to the planets. And it stays pretty close to the plane of the solar system, a low inclination. And this specific path brings it quite close to Venus, Mars, and Jupiter.
Close flybys of multiple planets.
Right. And they suggested, well, maybe that's not a coincidence. If it were artificial, maybe that path helps it make observations or, even drop off smaller devices near these planets without being easily seen.
So a trajectory that looks potentially strategic. Is that the idea?
Kind of, yeah, that's the implication. And then there was the sun.
Ah, yes. What about the sun?
The object is set to pass behind the sun from our perspective on October 29th. Loeb and his team suggested this could be, well, intentional, a way to maybe hide during perihelion.
Perihelion, its closest point to the sun.
Exactly. That's usually when comets are brightest and most active, easiest to study. So hiding then would be convenient if you didn't want to be observed.
Okay, that's definitely a set of intriguing points they've raised. But we need some context here, right? You mentioned Loeb himself framed this paper in a specific way.
Yes, and this is really crucial. He actually called the paper a pedagogical thought experiment.
But thought experiment. Not a definitive claim, then.
No, not at all. He explicitly acknowledged that the comet explanation is still the most likely one. It's more like, what if? Exploring the possibility. That nuance often gets missed, but it's important for understanding his position.
That nuance is key because, well, the reaction from the rest of the scientific community has been pretty strong, hasn't it? Overwhelmingly skeptical.
Oh, yeah. That's putting it mildly. The pushback has been significant.
Why such a strong rejection?
It boils down to this. Most other observers are reporting classic cometary behavior. They are seeing a broad coma. They are detecting dust and gas emissions.
So the exact opposite of the no outgassing argument.
Pretty much. To most astronomers looking at the data, it looks, well, exactly like a comet should look under these conditions. The evidence just seems to strongly favor a natural interstellar comet.
And some of the criticism has been quite pointed, right? I saw quotes calling the probe idea nonsense on stilts.
Yes, some experts have used very strong language. Samantha Lawler, Daryl Seligman, Chris Lintott. They've basically said the theory is unsubstantiated, that it distracts from the real science being done on this rare object. Some even called it insulting to the broader effort.
Wow, that's intense.
It really highlights the core principle here in science, doesn't it? Extraordinary claims require extraordinary evidence.
And the evidence for an alien probe just isn't there right now.
Correct. At least not according to the vast majority of the astronomical community looking at 3ILS. The extraordinary proof is missing.
Okay. But despite all that skepticism, Loeb has another idea related to this. Something about the Juno spacecraft.
Yeah, he floated a pretty bold follow-up idea. Could we maybe repurpose the Juno spacecraft, which is currently orbiting Jupiter, to actually fly by or intersect 3ILS?
Intercept it. When?
The potential encounter would be around mid-March 2026. The idea would be to get really close-up data, figure out its nature directly.
That sounds ambitious. Is that even feasible?
Well, that's the big question. There are serious doubts about whether Juno has enough fuel for that kind of major detour and whether it fits with its primary mission goals. Most mission planners think it's a real long shot. Probably not going to happen.
Okay, so let's bring it back to right now, end of July 2025. Where do things stand? What's the consensus, and what should we be watching for?
Right now, Loeb's claims about it being a probe are still speculative. They haven't been peer-reviewed, and they haven't gained traction in the wider community.
So the prevailing view is still comet.
Yes, overwhelmingly. The expectation is that as more data comes in, especially spectroscopy, looking at the light to see what chemicals are present.
Like water ice or CO2?
Exactly, evidence of those common cometary volatiles in the coma. The expectation is that this will just confirm it's a natural interstellar comet, and also tracking its movement, its dynamics very precisely.
So what would change the game then? What would actually make scientists sit up and say, whoa, maybe it isn't a comet?
Well, something truly anomalous. Detecting some kind of artificial propulsion system. Picking up unambiguous radio signals coming from it. Seeing it maneuver in a way that just can't be explained by natural forces like outgassing or gravity.
Anything like that been seen so far?
Absolutely nothing. Zero reports of anything like that. So everyone's watching very closely with ground telescopes, space telescopes, hoping to nail this down.
Okay, so wrapping this up, it's a fascinating situation. This deep dive really highlights that core tension, doesn't it?
Definitely.
On one hand, you have what's most likely a natural wanderer from another star system, just passing through. Yep. Amazing in itself. Good. On the other, this incredibly speculative but, undeniably intriguing idea of a technological artifact.
Right, and while that probe idea really grabs the public imagination, and it does touch on these huge philosophical questions about, are we alone?
Yeah.
The scientific consensus right now, based purely on the evidence we have, is firmly pointing towards natural interstellar comet.
Still an incredible object to study, regardless.
Absolutely, and the fact that we're scrutinizing it so intensely, debating these possibilities so openly, shows how seriously science is now looking for any sign of life or technology out there. Every little anomaly gets looked at.
And maybe that's the final thought for you, the listener, to mull over. What does this whole debate, whichever way it ends up going, Tell us about science itself.
Yeah, how do we balance that really important, bold curiosity, that willingness to think what if, with the absolute need for hard evidence, for rigorous testing, for peer review, especially when we're staring into the cosmic dark, dealing with so many unknowns?
What does it even mean to be well-informed when you're right at the cutting edge, where ideas are literally being formed and challenged in real time? Something to think about.